for question 41, this is a optimization question. And it's very common for our max min questions. We have a cone, and we're finding the closest point to 420. So let's get the function first, actually, of what we're going to draw, and we're calling this the objective function, xyz. And this is going to be actually the function to get the distance to 4, 2, 0. And just for sakes, we're going to square everything so we don't get nasty square roots in our optimization question. And what we're basically is finding since we're finding closest, is looking at the minimum. Now, here we'll have to reason that a cone, which basically is going to look like this, has a minimum, and we kind of see that it does, but it doesn't have a maximum because it's always increasing. So we only need to look at our critical points, and we don't need to use the second derivative test or see that this isn't even a closed bounded region. We'll only look at our critical points, and the only critical point we'll get is at that minimum because there's no maximum, so there's no worry that we'll get anything else. So we'll use our constraint and basically plug in this value into here. So our function is going to look something like this. And if we actually expand, let's add the 2x squared here. We can get our critical points pretty easily by getting the derivative in respect to x and derivative in respect to y. Sorry, there's no squared here. And set them both to as 0, like we've done for all the critical points, and that gives us x equals plus 4, and y equals to 1. So 4, 1, that is our only critical point, and that basically by reason we know that this is our minimum, and our relative minimum is going to be our only minimum, so our absolute minimum, and the z value corresponding to this is going to be either a plus, because this is 17, if we z squared is 17, it's going to be plus 17, plus or minus 17 in the end. So our points, 2 points actually, is going to be 4, 1, plus root 17, or 4, 1, negative root 17.